All right. Unit 7, Section 4, using the trig ratios to find sides. When we did trig ratios in the last section, we had all of the sides, or we used two sides and the Pythagorean theorem to find the third side. And what we could do then is find the measure of the angle, right? The sine of the angle equals that fraction. So if you do sine and then type in the angle, you should get that fraction's worth as your answer. But we can use that and create an equation in order to find a side that's missing, as long as we have a side and an angle. Now, something very important, which I just learned because I just recorded this, started recording it, and then I was in the wrong thing. So make sure your calculators are in degree mode. So a good thing to do on Desmos, it's this little wrench up in the top right-hand corner. And then you want to make sure that you're in degrees, not radians, okay? If you're on any other type of calculator, you're going to go to mode, and it's down in the angle portion down here. You want to make sure that you are in degrees there. So both of our calculators working correctly right now. I'm going to go ahead and just do a little split screen because we're going to need it a lot. All right, let's look at the first one. The angle in question is this one, number 28. And so if we go to this way where x is, that is on the opposite side. And this is opposite of the 90, so that is the hypotenuse. So I have OH, and so that would be SOHCAHTOA. So the sine of 28 degrees should equal some number over 19. And what we want to do is solve for that number. So we want to get x by itself. So we want to get rid of divide by 19 by multiplying by 19. And so x is going to be approximately, now it says round to the nearest tenth, so we're going to round to the nearest tenth. So we're going to go to functions, and we're going to say the sine of 28 degrees times 19, and we get 8.9. 8.9 is how far we should have for that one, okay? Now let's look at number 5 here. 41 is the angle in question. This side is opposite. This side is touching, so it's adjacent. OA is TOA, so the tangent of 41 degrees should equal x over 32. And we're going to get rid of the 32 by multiplying. So x is going to be approximately, this way I can just do 32 funcs tan, and it was 41 degrees, and we get 27.8, 27.8. Just like that. Identify the angle, figure out which pieces you have, figure out which part of the trig you need, the SO, the CA, or the TOA, and create your equation and solve. So let's look at number 6 here. Looking at this one. That's touching, so that one's called adjacent. This is opposite the 90, so that is my hypotenuse. AH is CA for cosine of 21 degrees equals adjacent over hypotenuse, which is 26. So we're going to get rid of the 26 by multiplying. And so we're going to say 26 times the cosine of 21 degrees, and x is approximately 24.3. Et voila. Let's look at number 7. 55 is what we have here. This one over here is opposite. This one right next to it touching is adjacent, because this is your hypotenuse. So we got OA, so that's the tangent of 55 degrees equals x over 8. So multiply by 8 both sides. X is approximately 8. That's a 9. 8. The tangent of 55 is 11.4, rounded to the nearest tenth. Very good. Give it a pause. Try 8, 9, 10, 11. Come back and let's see what you get. Okay, here we go. In question, this is opposite. This is hypotenuse. So that's the sine of 33 degrees equals 15 over x. Now, what we have to do is get rid of the x. But what we can remember is when we talked about ratios, you can get one diagonal swap. Okay, so we can actually switch that so the x is over here and then it's 15 over the sine of 33 degrees. It's the same thing as saying, okay, well, if I want to do instead, I could say, okay, times x, and then we divide by sine 33, we divide by sine 33, and now it's just the sine's on the bottom and the x is on the top. So you can get that one ratio diagonal swap, and you're good to go. So let's do it. 15 divided by the sine of 33 degrees gives us 27.5. So x is about 27.5 degrees. We know this one in 9. We know the adjacent piece. We know the hypotenuse. That's so that's ka. So the cosine of 43 equals the adjacent 36 over x. We're going to do that one swap. So x equals 36 divided by the cosine of 43. So we got 36 divided by cosine of 43. So x is approximately 49.2. Number 10, 72 is in question. We got one touching, so that's an adjacent. We got one that's opposite, so that's TOA. So the tangent of 72 equals opposite 25 over adjacent x. Give them the swap. X equals 25 over the tangent of 72. So x is approximately, let's see, so 25 divided by the tangent of 72 is approximately 8.1. Give the old circle. 64 is the one we got next to, and what do we got? We got next to, and this one is the hypotenuse. So next to is adjacent. So that's cosine of 64 equals the adjacent x over the hypotenuse, 11. Oop, not what I wanted. So we're going to multiply by 11 on both sides. So x is approximately, let's see, close that one out, 11. And the cosine of 64. And we should get approximately 4.8. Perfect. Now, this brings on word problems. This is where you're going to see most of the word problems in geometry. It's going to deal with right triangle trig. So SOHCAHTOA is going to be very important. But all you have to remember is that just draw a picture. Jake leaned a 12-foot ladder against his house. Okay, well, draw his house. And here's his ladder. We know it's 12 feet. If the angle formed by the ladder and the ground, so that's down here, is 68 degrees, how far from the base of the house did he place the ladder? Well, that would be this part, which is adjacent. And here's my 90 with the house, so that makes this my hypotenuse. So, so the cosine of 68 equals adjacent x over hypotenuse, 12. Multiply by 12 both sides. So, 12 cosine 68 is 4.5. So x is approximately 4.5 watts, 4.5 feet away. Okay, go ahead and give it a pause. Draw and try 13. Come back. Let's see how you did. All right, a ramp is used to load suitcases onto an airplane. Okay, so you got to draw an airplane. So here's my airplane. Let's see, it's got a little wing here. It goes this way, and then there's a wing, and there's a plane, there's another wing, then there's the body of the plane, there's the tail of the plane, and there's I don't know, wings, that kind of thing. I don't know, it looks like a giant messy X, but there's a bay window, right? And there's a ramp. Now, a ramp is used to load suitcases on an airplane if the cargo door is 7 feet from the ground, so 7 feet high. And the angle formed by the end of the ramp and the ground is 25 feet, so if we look at it sideways, it's 7 feet high, and this is 25 degrees. Here's my 90, okay? How long is the ramp? So that's my hypotenuse. It's across from the 90. This over here is the opposite. So that's sine 25 equals opposite 7 over x. We're going to do our swap. So x equals 7 divided by the sine of 25. So 7 divided by the sine of 25 degrees. So x is approximately 16.6 feet long. And that's using trig to find a side when you have one side and an angle.